Hello students, welcome you all in this video where I am solving model question paper 3 for the year 2025-26 and I am going to solve 3 marks question from part A physics. So let's start with the question. So now I'm going to start with 3 marks question. Already 1 marks question and 2 marks question, both the videos I have uploaded. Go through my channel, watch my videos. If you like my videos, share my videos with your friends. And if you're not still subscribed my channel, please consider subscribe my channel if you're getting little bit also help from my all these videos. So let's start with the first question, that is question 8. So Roman number 3, answer the following question. Here we have to answer 3 questions. Each carries 3 marks. So total we are going to get 9 marks from this section. Question number 8 says, draw the diagram to show the image formation when when an object is placed between 2f1 and f1 of a convex lens. So we have to draw the image or the ray diagram for convex lens when your object will be between 2f1 and f1. With this, we have to mention the position and size of the image formed. So we have to write what is the position and what is the size. Sometimes nature also will be asked, but here in this question they have not asked, they have asked only position and size. So this we have to write it. Then for extra information, they have given F1 is the principal focus of the lens. This is for your just extra information. By using this, you can draw the diagram. So let's take first convex lens. So this is the convex lens. And now we are going to draw first principal axis for this. So this is the principal axis. Let's name it as X and here I'll write it Y. Then at the center there will be optical center. I'll write it O. Then here there will be F1, that is principal focus, and here there will be 2F1. Then this side also same thing, we have to write here I'll write F2 and somewhere here I'll write 2F2. Because these lenses are made up of 2 mirrors, it is a combination of 2 mirrors. Therefore here we are going to get a principal focus that is on the 2 sides. So here I'll write F1. If this distance is same equal to this distance, then this will be 2F1. If this distance and other sum, this distance is same, then if this is 2F2, then this will be 2F2. So this is the labeling. And now what we have to do according to question, where we have to keep our object should be between 2F1 and F1. So in between these, somewhere here we are going to get the object. So let's take the object. So this is the object. Here I'll write it as A. I'll label it as A. Now from this object, some rays will be parallel to the principal axis and some rays will pass from this optical center like this. And once they pass from the parallel from this lens, it get refracted, and the ray which is going from optical center, it goes straight. And this both the rays will meet somewhere on this side. And wherever they will meet, we are going to get our image. So let's draw the rays. Now see, this is the ray which is going parallel to the principal axis, and after refracting it gets bent and it passes from this principal focus, that is F2, and the ray which is going from the optical center, it goes straight, and these both the rays after refraction they are meeting here. So here we are going to get our image, that is after 2F2, or I can say beyond 2F2. So let's draw the image. So this is our image. So I'll write it here as A dash. So now if you see, so here we have finished the first question in this, because this question is divided into 2 parts. Draw the diagram to show the image formation. So I have completed the drawing of this diagram. Now we have to mention position and size of this image. So what is the position? It is beyond 2F2. You can see this is 2F2. Beyond 2F2 we are getting our image. So the position is beyond 2F2. So I'll write it here. Position of image. So what I should write it here for this? I will write beyond 2F2. Then they have asked size. So I'll write it here. Size of image. You can see the size compared to object. Our image is big. So I'll write it here enlarged. I should write it here enlarged. Sometimes they will ask nature. In this question, they have not asked the nature, but sometimes they may ask. So just for your information, I am writing here nature also. So nature of images. What is the nature? You have to write. It is erect or inverted, real or virtual. So if you see the image, it is real. because it is forming on the other side of the lens. So I'll write it here, real. And what about the position? It is inverted. So you can understand. I hope you can understand what is inverted and what is real. Here object is erect, but this image is reverse or invert, therefore it is inverted. And whatever images we will get it on the other side of the lens, on this side, those all will be real. So therefore I have written real. So here this is the nature of the image. Remember, in this question, such type of question, if they ask only position and size, then you should write only position and size. Don't write this nature. This is just for your information I have given in this question. So this is the answer for question number 8. After this we are going to move with question number 9. Question number 9 says, what is presbyopia? Mention the reason and suggest remedy for this defect. So this is the defect which will be formed. So we have total 3 defects in our NCERT book: myopia, hypermetropia and presbyopia. So this is the presbyopia which is asked. And what you have to write it here, what is presbyopia? So we have to define this presbyopia, and then we have to write the reasons why it is formed, and then how to correct it. That is the remedy we have to write. So the answer, what is presbyopia? It is the defect of vision in which person cannot see nearby objects clearly due to old age. So due to the old age or due to the increase in the age, the person cannot see nearby objects clearly. Such type of defect it is called as presbyopia. And what are the reasons? As the age increases, so see here, with increase in the age, the eye lens becomes less elastic. So what do you mean elastic? Elastic means the eye lens will try to decrease or increase in the size so that we can see the objects which are present on far distance or nearby distance. But due to the increase in the age, the property of elasticity or property of increasing or decreasing the size of the lens will become less. It will not immediately change its size. Elasticity will be decreased. So it will not change the size of the lens so that we can see the objects which are present on nearby or the far distance. The second reason, ciliary muscles weaken and cannot change focal length of the eye lens. Very simple. It is related to the first reason only. The ciliary muscles which are responsible to change the focal length of the eye lens depending on the position of the object, those will get weakened due to the old age. So because of this, to see the objects which are present on different distances, the focal length of the lens should change, and that is not possible due to the weakness of the ciliary muscles. So these are the two reasons. How to correct this? What is the remedy? The remedy is presbyopia can be corrected by using convex lenses of suitable power. So here we can use convex lens. And remember, depending on the power, depending on the disease of the particular person, the suitable power convex lens will be used. It is not that you can use any type of lens. You have to go to the doctor, you have to get a checkup, and you have to see at what distance you are not able to see the object. And depending on that, the lens will be suggested. Means suitable power lens will be suggested to the patients. Then, if the person also suffers from myopia, then bifocal lens has to be used. So what do you mean by myopia? See here, presbyopia means person cannot see nearby object, and myopia means person cannot see far object. So if you have these both, then you have to use bifocal lens. Bi means two, focal means focal length. So focus. So there will be two lenses, convex as well as concave. And these both the lenses will help to see the objects present on nearby distance as well as on the far distance. So this is the remedy for this presbyopia disease. So I hope you understood the answer of this. Now we are going to move with the next question. So this is the OR question. Then here this is also from the same chapter. What is short-sightedness? What are the reasons for this defect and how it can be corrected? So see the question pattern. Both the questions are same, but the pattern of asking the question is different. See what they have told. What are the reasons for this defect and how it can be corrected? Earlier they had asked remedy. Remedy is nothing but how it can be corrected only. Just you have to understand the question properly. Now see, what is short-sightedness? This is also called as myopia. So myopia is nothing but short-sightedness. Short-sightedness is a defect of vision in which person can see nearby objects clearly but cannot see distant object clearly. Remember, myopia means what? Myopia disease is also called as short-sightedness, where person can see nearby objects clearly. Whatever objects are present on the nearby distance, he can see clearly, but the objects present on the far distance, he cannot see clearly, or he can see little bit of blurred vision. Such type of disease is called as myopia or short-sightedness. What is the reason for this? The eyeball becomes longer than normal or focal length becomes smaller. Meaning is same. The eyeball present in the eye will becomes longer compared to normal. So whatever size we have normally, compared to that, the eyeball becomes longer. So that's why the focal length will become smaller and you will not get the image formation on the correctly retina. Therefore, we cannot see the object which is present on the distant or the far distance. So how it can be corrected? It can be corrected by using concave lens. In concave lens, whatever rays are emerging before the retina, those all will correctly beat it on the retina. And that's why you can see the object clearly. So remember, the correction of this is, in case of myopia, we can use concave lens and that is also of suitable power. So depending on the patient, depending on the disease, doctor will suggest the suitable power concave lens to the patients. So this is the answer for this or option. Either this you can answer or the earlier question you can answer, whichever you feel easy. I used to tell always, remember, first read the question, understand the question. If you are comfortable, if you feel that you can write clear and correct answer for that, then only you can choose that question. So first, whenever such type of internal choice is given to you, always first you should read both the question clearly. Now we will move the next question. Now we will start with question number 10, where we have options A and B. So what are the reason for overloading in an electric circuit? So it is the question from electricity chapter. So we have to explain the reasons. You have to write the reasons for overloading. So the answer is, overloading in an electric circuit occurs when excess current flows through the circuit. So why overloading will cause? Due to the excess flow of current through the electric circuit. So the reasons you can write it like this in the 2 points. When many electrical appliances are connected to a single socket at the same time. So you maybe have seen in home there will be many appliances will be connected to the single socket. Like for example, for the single socket, sometimes you will connect the laptop pin, sometimes you will connect the charger, mobile charger pin, or some other appliances pin. So that should not be done. So that is the reason here. Many electrical appliances are connected to a single socket. So you should keep the sockets separate for all the appliances. Means if you want to use the laptop socket should be separate. Charging, mobile charging socket should be separate. So like this you have to keep. Then the second is due to sudden increase in the voltage in the supply line. From the direct supply, whatever the supply we are getting into the houses, if there is a sudden increase in the voltage, then also you can see this overloading. So these are the reasons for overloading. Now the B is, what is solenoid? How can electromagnet be prepared from a solenoid? So first we have to define solenoid. Solenoid is a long coil made by winding insulated copper wire closely in the form of cylinder. So what is solenoid? It is consist of insulated copper wire, but that copper wire is coiled around a cylinder. So for example, first let's see how it is prepared, then I will show you. So preparation of an electromagnet using solenoid. So now we are going to see how it is prepared. So the first step, take a solenoid and place soft iron core inside it. So what is solenoid? Solenoid is nothing but we are going to take a cylinder like this. So this is the cylinder. Imagine it is a cardboard cylinder, and around this cardboard cylinder we will take a copper wire which is insulated, and like this we are going to coil it. See, like this. And now if you remove this cylinder, which is a cardboard cylinder, from this copper wire, it will look like this. It will take a shape of that cylinder, and this is nothing but it is called as solenoid. So this is solenoid is ready. Now we are going to see how electromagnet is prepared. So take a solenoid and place a soft iron core inside it. So we will take a solenoid like this. This is a solenoid, and inside this solenoid we are going to keep a soft iron core. So this is a soft iron core which we have kept it inside the solenoid. Connect the ends of solenoid to a battery through a key or a switch. So take this copper wire and connect it to a battery like this with a switch. So this is a switch. Like this we have to connect it. Third, when electric current flows through the solenoid, the soft iron core becomes magnetized. So once the switch is closed, the electricity will flow into this wire. As the electricity is flowing into this wire, the magnetic field will develop in this wire, and these all magnetic field will get added, getting sum up, and this whole wire will get magnetized, and that magnetized property will go inside this core, which you can see here, soft iron core, that will take that magnetized property, and this whole iron core will get magnetized. Thus, the solenoid act as a strong magnet. So see here, we have not used any magnet. We have just used this battery. With the help of battery, as the current is moving in the wire, here everywhere magnetic field will develop. See this magnetic field lines. So, and these all magnetic field lines will develop a strong magnetic field. And due to this strong magnetic field, this inside the blue colored iron core you can see that will get magnetized and it will act as a magnet. So these are the steps to prepare an electromagnet from a solenoid. So this is the answer for question number 10. After this we are going to see question number 11. So question number 11, sorry, it is not question number 11, it is the OR option for question number 10. So either you can solve earlier question or this. This question is also divided into two options, that is A and B. So see here, mention the properties of magnetic field lines. So we have to write the properties of magnetic field lines. So see, first property, magnetic field lines originate from the North Pole and ends at the South Pole outside the magnet. So whatever magnetic field lines are formed around the magnet, those all will originate from the north and ends at the south, and that is outside the magnet. This you have to remember. Let me show you with the help of diagram. So this is the bar magnet. Then here I'll write north and here I'll write south. Then whatever magnetic field lines are produced, those will be like this. This is first, second. I'll draw three magnetic field lines. It will be easy to explain you all like this. So see, these all the magnetic field lines will originate from the north. See the arrow. They are coming from the north and merging at the south. See, this is the arrows. So they are emerging from the north and merging at the south, but this is outside. So these all the lines are outside. So remember, this all is outside the magnet. Second property, inside the magnet they go from south pole to north pole, thus forming closed continuous loop. It is correct. See here, once the magnetic field line emerges from the north, it goes and merges at the south. From the south, from inside the magnet, it will go like this and it completes the circuit. See here, inside the magnet, it is going from the south to the north and completing the circuit. See, if I'll change the color, if this is the line, see, emerging from the north, going towards the south, merges at the south, and once it go to the south inside the magnet, it goes like this to the north. So remember, inside the magnet from south to north, outside the magnet from north to south, and so that it will complete a circuit. So it will be a closed continuous loop. Now, no two magnetic field lines intersect each other. Yes, these magnetic lines will never intersect. See, this line will be different. See, this line will be different. This line will be different. For example, if this is a magnet, if this is the first magnetic field line, second cannot be like this. They will never intersect, remember. Fourth one, the closeness of field lines indicates the strength of the magnetic field, correct. So here, the closeness of this magnetic field lines will indicate the strength of the magnetic field. If the closeness is more, strength of the magnetic field will be more. If the closeness is less, strength will be less. And depending on this, you can see the lines are very close when they are near to the poles. When they go away from the poles, you can see here, when they go away from the poles, the lines will be far from each other. And due to this, the magnetic field strength will be more near the poles and less will be away from the poles. So the next one, magnetic field lines are denser near the poles. So the same thing which I have explained just now. Magnetic field lines will be always, remember, they will be denser near the poles. See this, both the sides, this side as well as this side, both the side, magnetic field lines will be closer at the poles and they will be away, they will be far when they are away from the pole. So these are the properties of the magnetic field lines. Maximum times 3 properties will be asked. Remember all 5. Whichever you feel easy, those properties you can write in your question. Now the next one. When the number of turns of current carrying circular loop is increased by 10 times, what change occurs in the magnetic field produced in it? See the question what they have asked. When number of turns current carrying circular loop is increased by 10 times, what change occurs in the magnetic field produced in it? Let's see the answer. So according to question, see here, if this is the copper wire, first turn, second turn, third turn, and this is the fourth turn. And these both the wires are connected to this battery. Now see, when the current is moving in this wire, at every point in this wire, it will form magnetic field lines, this magnetic field like this. So these all are the concentric circles of magnetic field lines. And as many concentric fields of magnetic field lines are formed, that much of magnetic field strength will increase. So in this coil, in the first turn, if in the first turn I have drawn 3 concentric circles, then in the second turn there will be again 3 concentric circles. Then in the next turn there will be again 3 concentric circles. And like this, if you increase these turns in the wire, these concentric circles of magnetic field will be go on increasing. And these magnetic field lines are responsible to increase the strength of the magnetic field. So therefore, the answer is the magnetic field produced by a current carrying circular loop is directly proportional to the number of turns. See the same thing I told. Magnetic field and this turns, number of turns, both are directly proportional. If you increase the number of turns, magnetic field strength will also increase. And therefore, so when the number of turns increased by 10 times, the magnetic field strength also increased by 10 times, provided the current remains same. Yes, we are not changing the current. Battery same as it is. Current we are not changing. We are changing only the turns. So as you increase the turns, that much of magnetic field strength will go on increasing. So this is the answer for this question B. I hope your my all the videos are helping for you people to prepare for your final exam. If you like my videos, if you are getting little bit of also help from my all the videos, then share my videos with your friend and please consider subscribing my channel so that I can prepare more and more videos for you all. And if you have any doubts, then those all the doubts you can comment in my videos so that I can solve those all the doubts and upload it. Those may help to all the students, those who are watching my videos. Thank you so much.